the zigzag operation or zigzag operation depends on the direction you're pushing. You will push the element twice. You need change the element twice. So what happened here? You don't push the two to right then the right again. You push the element forward, the element between the zig, the element to display, and the destination, which is the 3. Make a zig rotation with that first. So we have 3 here, here gonna be the root, and we have 3, the 5 comes down, the 6 down 2, and the 4 becomes a child of the 3, and the 4 becomes a left child of the 5, and the 2 keep a child of the 3, just that. And then you're gonna rotate the number 2 to the root node. Well, the amortized analysis. This analysis was taken in a paper with the lecture of David Carter and scribes of Xin Zhang. The link to the paper, it's gonna be on the description of the video. Well, we'll start with some definitions. We have a constant, which is the weight, double Wx have to be greater than 0. The sum of these weights, it's called S of x. It's equal to the summation with all elements of sub 3 of x, including the x element, and sum all these numbers, all these constants. If you have a constant that it's 1, this sum it's gonna be represent the number of elements of the sub 3 plus 1, because x is included on the count, and this could call it size of the sub 3. And this actually is used by others analysis, but could have other constant too. Don't have such difference. The rank is Rx is equal log S x. The Rx is the potential of a node. The potential function to make the analysis after I operations is thus phi I equals summation of all elements of the tree through the function of R, which is the log of the sum of the weights. Okay. Lemma 1. The amortized cost of a Splay step on node X is that expression where R is rank before the Splay step and R quote is rank after the Splay step. Furthermore, the amortized cost of the RR, LL, LR, and RL Splay steps is this operation. This these letters R, R, L, L represent the rotation to the right with R and rotation to the left with L. So this could be zigzag, zig-zig, zigzag, or zag-zig. And why it's different the rank before Splay step and the rank after the Splay step? Because after I Splay, the element will change his position. So the subtree of the element could be changed. Like this example where we have a zigzag or RR Splay steps. The X element was here in beginning and he become the root node. Here the rank is the sum of the rank of A and the rank of B plus the rank of X as plus the S function of X. And here you have to sum A, B, C and D plus Z and Y to calculate the rank of X. So it's different. The proof. We'll consider only the RR Splay step, referenced by the figure 3.1, this one, and the other Splay steps is analogous to this one. The actual cost of Splay step is 2 for 2 rotations, and the Splay step only affects the potential ranks of node X, Y, and Z. The others will be the same. We observe that R, X is RZ. RY is greater or equal than Rx and R quote Y is lesser or equal than R quote X. So X quote is equal to Z. X quote is equal the rank of Z, right? Rank of Y is greater than rank of X. The Y is greater than the rank of X. Okay, greater or equal. And the rank quote Y is lesser than rank quote X. Is this true too? So the amortized cost is equal to for the actual cost plus phi I plus 1 is the step before, is the rank before, is this the potential of I plus 1 less the potential function of I operations. So we have this, all ranks before, all ranks before and this is all X after and all ranks before. Using this, we have 0 that, and we can use these definitions to represent an equation, and we become with this expression. So using a property of the logarithmic, that we have log of a plus log of b divided by 2 is lesser than log of a plus b divided by 2. So using this property and some manipulations of the math, we have it we have this expression, and we note that r comma z is lesser than 2r quote x less rx less 2 of that. Why this is true? This is only the definition at the beginning, but this actually happened because the x quote s quote x is the sum of the z and y and the x property. So the x is the sum of z and y is greater than the x before the display step. So this is really true. With the expression we have got earlier and this new one, we have a substitution here. This is gonna be 3 r quote x. This is gonna be 3 r x. The number 2 less 2 is gonna be 0. Thus, the amortized cost of the RR display step is 3 times of the difference between Rx after the display and R before display step. The same inequality must be held for the LL display step and the other ones. The plus one in the lemma applies for the R and L cases.